This is the video for lesson 7.7. If you would please make sure you're using a pencil and then go ahead and fill in the learning target. You are going to be able to use the inverse sine, inverse cosine, inverse tangent to solve a right triangle. So one of the vocabulary, the only vocabulary that we have in this lesson is to be able to solve a right triangle means to find all of its side lengths and angle measures. So in the previous lesson we were learning about the sine, cosine, and tangent ratios. We're still going to be using those, but in this lesson we're going to actually use the inverse, okay? The inverse means that you're going to be able to find an angle measure based on those ratios, and before we were only finding lengths of sides using the trig ratios. So now, because we have the inverse tangent and we want to be able to solve for an angle measure, that's what this is useful for. So if you look at the next thing on your note sheet, the inverse tangent looks like this in terms of what it actually, how it's written, tangent to the -1 power. Inverse sine is written like this, sine to the -1 power. Inverse cosine is cosine to the -1 power. But if we look a little bit closer at this, if we're trying to find the measure of angle A and we don't know what that angle measure is, if we use the tangent, we can use the opposite side, that's BC right here, over the adjacent, AC, okay? And if we use our calculator and type in inverse tangent, okay, you're going to have to touch the second button on your calculator, that blue button, and then the function. So in this case it would be tan, right? So second button and then tan, that's going to be the inverse function. And the reason we use the inverse function is to find angle measures. And remember, the point of this lesson today is to solve a right triangle, and that means that you're not just finding side lengths like we've been doing in the previous triangles we were solving. Now we're going to find the angle measures as well, and these inverse functions are going to help us find the angle measures. Okay, so our first example here says use an inverse tangent to find an angle measure. Use a calculator to approximate the measure of angle x to the nearest tenth of a degree. Tenth is just one decimal place. So we're looking for angle x. We do not know what angle x is. That's what we're looking for. And because we know that we're supposed to use tangent, we will. But if we didn't know tangent, we can see that this side is opposite from angle x. This side is adjacent to angle x. So that's always going to refer to the tangent, because remember our abbreviations. So that's sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. TOA, that's the tangent, equals the opposite over the adjacent. So remember, in this triangle we're trying to find an angle measure. So we need to use the inverse function. So angle x is going to equal tangent inverse, so to the -1 power, and in parentheses you'll just write the opposite side over the adjacent side. So the inverse tangent of 7/5, and if you plug that into your calculator, make sure, remember, you're going to hit the second button, so that blue button up in the upper left hand corner, and then the tangent button, and then 7, put this in parentheses of course, 7 divided by 5. That's going to give you, and of course round it to the nearest tenth, 54.5 degrees. So angle x is 54.5 degrees, and if you were able to find that one, then you could find z just as easily, because remember, these two acute angles have to equal 90 degrees, because this one is 90 and the whole triangle has to add up to 180. So that gives you an idea of how to use the inverse tangent. And I would like you to try that with problems 1 and 2. And again, use the inverse tangent, round to the nearest tenth of a degree. Okay, let's take a look at example 2. It's asking us to use the inverse sine and the inverse cosine, and that's going to help us find the measure of the angle that they're asking for. So it says right here, let angle A and angle B be acute angles in a right triangle. Use a calculator to approximate the measure of angle A and angle B to the nearest tenth of a degree. So it tells us in part A here in this problem that sine A equals 0.19. Well, 0.19 just means that this fraction, we could turn this decimal into a fraction, and it is going to be 19 over 100. So looking at the position from angle A, because it says sine A, the opposite side is on top and the hypotenuse is on the bottom or the denominator. The opposite side from A is 19 and the hypotenuse is 100. And we are trying to solve for angle A. This is the angle that we don't know, and this is the angle that we can find based on the information that we're given. So angle A is equal to the inverse sine of 19 over 100. Or you could say inverse sine 0.19 if you want to enter that into your calculator. And the result is going to be that angle A equals 11 degrees. Now, if we know that angle A is 11 degrees, we have to subtract that from 90. So 90 minus 11, and that's going to be what angle B is equal to. So angle B is 79, angle A is 11. And we did all of that just based on knowing that sine A was 0.19. And if you need to watch that part of the video again, please do that. I will do the cosine now, which will be very similar. It's just that we know that the cosine is the adjacent over the hypotenuse, and this one is asking us to find use cosine B. So I'm going to be at this position in the triangle next to the angle B. 56 or 0.56, that just means that we have 56 on top, 100 on the bottom, and 56 would be the side that is adjacent to B because it's on the top, and the hypotenuse is 100. We can label that. So the adjacent side is 56, the hypotenuse is 100, and angle B is going to be equal to inverse cosine 56 over 100, or you could just type it in 0.56, that's fine as well. And when you do that in your calculator, you should find out that angle B is equal to 55.9 degrees. That's angle B. So if angle B is 55.9 degrees, we can subtract that from 90 and find out what angle A is. So the angle A is going to be 34.1. Remember, angles A and B in the triangle have to add up to 90. That's why I'm subtracting the original or first angle from 90. Those two angles are complementary. Okay, please check out the on your own problems on the back side of your paper. These are going to be just like the ones I was just showing you. So in your calculator, you're going to want to type in inverse sine. Remember, you're going to need the second button to do that, second and then sine. And then just type in 0.95, and that will give you the angle of A. And that's all they're asking you to do, is find the angle measure of angle A. All right, let's move on to example 3. We're going to solve a right triangle. So when we solve a right triangle, remember the definition on the front says that we need to find all of the angle measures and we need to find all of the side lengths. So we're looking for 6 answers total from this triangle. So if we look at it, we have angle D, we have angle E, and we have angle F. Do we know anything of the angle measures? Well, yeah, we do. We know that angle F is 90, right? We have that one. And we also know that angle D is 37. So obviously every angle or every triangle adds up to 180. So if I subtract those two numbers from 180, I'm going to find out that angle E is 53. So just remember, all of these have to add up to 180. That can be a pretty helpful hint when you're trying to solve for all 3 of those angles. Now you've been used to doing that, so that's not too hard. but we do need to find a way to find the lengths of the other sides. We need to find, well, let's fill in the one we have. Right now we have side EF is 14. We do not know what side DF is, and we do not know what side what length the hypotenuse is, DE. So when I identify those sides as sides, I want to name this one with the lowercase e, and I want to name this one with the lowercase f, and I want to name this one with the lowercase d. Not when I list them over on my table, that's not what I'm talking about. But in the triangle, notice that big E is going to be across from little e, big D is going to be across from little d, and then large F is going to be across from little f. So that's why we're naming them that way. So in the triangle, I want you to think about how you're naming the sides versus how you're naming the angles. Angles have capital letters, okay? Now, when I go to solve for DF, DF is really little e, and from the angle that I have, this angle, 37 degrees, is next to, that's the adjacent side, and little d is opposite from that angle. So as you know, opposite and adjacent go with the tangent function. So to set this problem up correctly, we're going to say tangent 37 equals opposite, which is 14, over E, the side that's across from large angle E. We're going to set this up with a 1 underneath there and then cross multiply. So 14, because I'm going to multiply 14 times 1, equals the tangent of 37E. Remember, this is a number. Tangent 37 is an actual decimal if you type that into your calculator. Now, to get rid of it on this side, we're going to go ahead and divide by tangent 37. And over here, same thing. So then that means that E, or the side called DF, if you name it with two capital letters, is going to be 18.6. And that's the length. So over here, DF is 18.6. And then we need to find the hypotenuse of this triangle. And you could find it by using the cosine. Cosine of 37 is going to be equal to, we already know this side now is 18.6, right? We just solved for that. So cosine is the adjacent, which we have, this is the adjacent side to 37, over the hypotenuse, which we do not know. So I'm running out of space a little bit, but over here we'll say F. This is where we're doing the F work. So cosine 37 equals adjacent 18.6 over F. All right, so after you get done doing all the work through the proportion, the final answer for side F is going to be 23.3. All right, I didn't do all the work there to show you in the video because I did all of this for you. And to shorten up the video, I just wanted to give you the answer here. So, like I said, solving a right triangle means that you're finding all of the angles. All right, most of the time you have at least one of the angles other than the 90. Sometimes you won't, though, if it's a tricky problem. And then you want to find all of the side lengths as well. So each time they ask you to find, each time they ask you to solve the right triangle, that means that you're finding 6 different answers, 3 angles and 3 sides. So I'd like you to check out the practice problems here at the bottom of the page. You have 2 of them to do. And just as a little hint for you, remember, you can solve for angle C pretty easily, right? Because we know that this angle 61 plus angle C has to equal 90. I'll just give you that hint. Same thing for angle A. This is very easy to find because we know that angle C is 23. So subtract 23 from 90, and that's going to give you angle A. All right, try both of these problems on your own, please, and thank you very much for watching.